Usually, when we think about Dr. Eggman's creation, we picture his greatest inventions, his iconic and destructive robots, his spaceships, his amusement parks, and all the other wild things this evil genius comes up with. I'm pretty sure that all those creations, along with the many factories it has scattered across the Sonic world, must bring in a ton of money. But how much does it actually cost him to make all of this? Well, it varies. Today we're going to look at how much Eggman spends on his machines and whether it would even be possible to build any of these robots in real life. We'll start with his cheapest one, and then move up to his expensive creation throughout this video. I'll just be talking about the cost of the parts, because all the robotic engineering is handled by Eggman himself. Let's begin with one of his iconic robots and our very first enemy in the franchise, the Motobug, a Bendnik based on a ladybug. First, we need to understand that these robots can be made with just a 3D printer. Sure, you could 3D print a replica, but trying to make a combat-ready robot out of filament isn't exactly the best idea. You need industrial-grade materials and components to make it capable of fighting in a real battle. This is especially true when it comes to balance. A single-wheeled robot might sound simple at first glance, but making it actually work is the hard part. For the locomotion system alone, you'd need a budget of between $4,000 and $9,000 for the motors, controllers, stability systems, and wheel assemblies. But don't forget, these things have to be fully autonomous. It would be pretty tough to manually control a single robot when you need to deploy at least 1,000 of them just to make the path a little challenging for Sonic. So each robot needs its own autonomous systems and sensors to make smart decisions. That includes a powerful compute system, plus spatial mapping systems and depth perception cameras to detect moving objects around it. All of those sensors and computing systems would cost roughly $5,000 to $12,000. The power infrastructure is just as important. Without it, the robot couldn't even turn on and do its Motobug things. A high-density lithium battery pack would be essential for good endurance and stable energy output, allowing the robot to operate for hours. It would also need a proper protection and voltage regulation system to prevent malfunctions. This whole power setup would run between $1,500 and $3,000. Now that we have all the internal systems, sensors and components, we need to build the outer body. The internal skeleton has to be strong but lightweight. An aerospace-grade aluminum chassis would work well. The outer shell needs to be impact resistant, so a fiberglass armor shell would help prevent the Bendnik from being destroyed too easily. Yeah, of course. Finally, the arms and claws need to be retractable and strong. Altogether, these external parts would cost around $11,000 to $22,000. Adding up all the systems, building just one Motobug would cost between $22,000 and $46,000, and I'm not even including lower costs. Eggman built this himself, but if you hired a professional team, they'd probably charge double what you spend on the parts. So yeah, making one of these isn't cheap. But what about a robot with much higher complexity, one capable of keeping up with Sonic's speed? Let's talk about how expensive Metal Sonic would be if we tried to build him. First, we should look at the official specifications of Metal Sonic from Sonic's Elite Manual. Using those details, we can figure out the budget needed to create an evil copy of Sonic the Hedgehog. Building a bipedal robot with the strength, agility, and speed of Metal Sonic is definitely not as easy as it looks. If the Motobug, one of the simplest robots in the franchise, was already difficult, imagine trying to make something that can break the sound barrier multiple times. There's a big problem though. In real life, it's physically impossible for a robot like Metal Sonic to reach the speeds he does in the games. His specs simply don't match with current technology. For example, no standard battery could power a bipedal robot like that. You'd probably need something like a gas turbine generator, which definitely wouldn't fit inside our evil friend. But even if we ignore that, Metal Sonic will still be a millionaire level project. The titanium frame and armor shell would be among the most expensive parts. High-grade titanium would need to be precisely shaped and pinned to match his build design, plus a PVD plasma coating to get that signature blue color. All of that could easily cost between $250,000 and $500,000. Then we have the high-density power drivetrain. Here's where things get really tricky. Integrating an electrical generator and ultra-compact hydraulic power system into a roughly 3-foot torso is almost impossible. But even if we could, it would require microturbines and a liquid cooling system to stop the robot from melting itself. That alone would cost around $150,000 to $300,000. By the way, this is a good moment to remind you all to subscribe, like the video, and share it with your friends if you're enjoying it. Next up is the hydraulic system. Without a good one, the robot would collapse under its own weight. Servo valves and titanium pistons would be needed just to make it walk properly. That system would cost around $300,000 to $600,000. Yeah, at this point it's clear this robot would never get built. And we haven't even touched the hardest part yet, Metal Sonic's AI. Creating a robot that can think and act independently, like he does in almost every Sonic game, would be an incredible technological feat. Even if we could try to replicate something like this, it would still be extremely expensive. Adding his signature visor on top of that brings the computing and AI system to roughly $80,000 and 150,000. All told, the just raw materials for Metal Sonic would cost between $780,000 and $1,550,000. Now I understand why Metal Sonic is one of the few characters in the franchise without many real-life versions, and even if we build him, he still wouldn't be able to run or levitate due to real-world physical limitations, so he's definitely one of the hardest to make viable in real life. But what if we go even further? How much would one of Eggman's massive constructions cost? Let's find out how expensive it would be to build the Death Egg. First, we need to estimate its size. There's no official measurement, but we can make some educated guesses by comparing it to Angel Island. The Death Star, which the Death Egg is clearly based on, is 140 to 160 km in diameter, but the Death Egg is much smaller. Looking at the cutscene where it crashes into Angel Island, we can see it's roughly 7.5 times the size of the Sandlopolis pyramids. Assuming those pyramids are the size of the Great Pyramid of Giza, each section of the Death Egg would be around 1.25 kilometers, giving the whole sphere a circumference of about 2.5 kilometers. Now let's figure out how much Eggman would spend on one of these toys. Spoiler alert, it's not cheap. A 2.5 km sphere would have an internal volume of roughly 8.18 billion cubic meters. Using an old warship internal density model, it would require about 800 million metric tons of steel and advanced alloys. And that's not even counting the giant Eggman's face on the outside. Then there's the issue of orbital logistics. It's impossible to build a 2.5 km space station on Earth because its own weight would cause it to collapse during assembly, and no rocket could lift it, so it would have to be built in orbit. But even with the best rockets in the world, lifting 800 million tons of material would cost between 80 and $160 trillion, and that's just for the fuel and launch infrastructure. Then we have power. You'd need military-grade nuclear fusion reactors generating terawatts of energy to power a 2.5 km sphere in space. That would add another $75 trillion to the budget. After that come the hangar base, life support, and command infrastructure. Since thousands of bandits need to be able to launch from it, you'd need extensive electrical grids, radiation-shielded wiring, localized artificial gravity, atmospheric scrubbers, and automated assembly plants. That adds trillions more. Putting it all together, the total cost to build one Death Egg would be roughly $121.2 trillion to $278 trillion or more. And here's the fun fact: Earth's entire global GDP is around 100 and 120 trillion per year. That means building just one Death Egg would require the entire planet to dedicate 100% of its economic output to the project for at least 3 years straight. Definitely not something we could ever do. Oh my god, no. That's it for now. Eggman's robots are definitely not something I'd want to invest in, unless I could sell one of them. If you enjoyed the video, make sure to subscribe, like, and share it with your friends. I'll see you in the next one. Bye bye.